Alrighty, so we refreshed our brains on taking out a greatest common factor, but now we're going to talk about actual grouping. So we're still in topic 2. We're only through a little bit of your notes so far, but the rest of this is all pretty quick moving. So it says write the following expression in factor form. So again, we're going to try to take out the greatest common factor, but we know that has to be the greatest common factor of every single term. So let's just take 28, for example, right? What are the factors of 28? Well, 1, 28, 2 and 14, 4 and 7, and that's it. Well, none of those numbers can come out of 21, right? And I would say take out a v, except 12 doesn't have a v. So really, there is nothing that can be factored out of all 4. There's nothing, okay? However, we're going to learn today that that does not mean we give up. We don't write prime. We don't say, yep, that's it. We actually have more that we can do. So remember that factoring is undoing multiplication, right? So we're going to do a problem here. Multiplication. We're going to do a problem that is multiplication. We're actually going to multiply it. And then see what our answer looks like and if we can get it back to the multiplication problem. So 2x squared times 5x. That's 10x squared. Nope, x cubed. There's an x there, huh? X cubed. Okay. 2x squared times negative 2, so that's negative 4x squared. 3 times 5x is 15x. 3 times negative 2 is negative 6. Now, looking at this answer, I should be able to take this answer and go back to my original problem, right? The only method I've taught you to do that so far is factoring. Looking at this problem, is there something that I can take out of all 4 terms? Well, no. Take 15, for example, right? The only factors of 15 are 1 and 15 and 3 and 5. Those do not come out of any of these other numbers, right? However, I'm not going to say prime. I can't say that this is prime because I know that it's not. It's the result of this times this. This would be like me saying, oh, well, 27 is prime. And someone saying, no, it's not. It's the same as 9 times 3, right? So if I can actually find a multiplication problem that matches my answer, it's not prime. So this is not a prime problem, but I can't factor out the greatest common factor. So our answer to that is a method called grouping, okay? And this is also how I would do this problem up here, okay? Grouping. So in your notes, I'm first going to just kind of walk you through the process, and we'll do some examples that'll make it all kind of come together. So factoring by grouping can only happen when there are 4 terms. And that's a little bit of a lie, just because that's all you're going to see in my class. You'll never have more than that, but you have to have an even number of groups and some other rules as well. But for the most part, only 4 terms. You're first going to check for a greatest common factor among all the terms and factor this out first if you can, okay? If you can. Sometimes you can, sometimes you can't. It just kind of depends. After that, if you still have 4 terms, you're going to find the greatest common factor for the first 2 terms in the problem, because there's 4, right? And then find the greatest common factor for the last 2 terms in the problem. Then you're going to write the polynomial as a sum of these products, consider the new terms, see if they have a GCF, and then refactor. Blah, blah, blah. This is the big kicker right here, okay? It's called grouping because you're going to group it into the first 2 and the last 2 and do it that way. So let's just practice. Looking at number 1, do all 4 of those have one greatest common factor? The answer is no, right? They don't all have an R, they don't all have an X, all have a Y, all have a 2. There's nothing that all 4 have in common. So we're going to try grouping. So I'm going to take the first 2 terms and just factor out their greatest common factor. So in this case, an R. We've got R times X plus 2Y. Just pause for a second and recognize that if you multiply that R back in, you would get that original statement we just had. Take the second tier, the last 2. Take their greatest common factor out, okay? So I've got K in common, so X plus 2Y would be left over, right? Well, I don't want to completely change this problem. And if I consider, again, multiplying this back together, I'm going to have 2 pieces. I'm going to have Rx plus 2Ry and Kx plus 2Ky. But if I look back at my problem, they were added together, right? Which means I need to have these 2 added together, which means I need a plus sign there, okay? Now, if you wrote all that, sorry, I'm erasing it. What I have now is a problem like I did in the last video. I can actually now look into the greatest common factor again between my new terms that I just laid out here. I now have 2 terms, 1, 2, okay? Between those 2, what is my greatest common factor? Well, they both have x plus 2y in common. And then if I look at what's left over, r and k. Okay? Now, if I multiply this guy out, I am going to come back to my original problem up here. So x plus r is xr, x times k is xk, 2yr, 2yk. Now, it's in a different order, but it is those four terms again. Okay? So this would be my final answer right here. Okay? Now, again, I could not find a factor that was common between all four at the very get-go, but that did not mean I was done. I just had to group it into two groups and then do the greatest common factor. So let's try this again. Looking at number 2. I'm going to take my first two terms, factor them, right? So I can take out a 5v squared. So I'm left with 5v plus 1. And take my last two terms, okay? I can take out a 6. Now remember I said before I want to combine these two things because they're being combined here. So I'm going to take out a 6. So I've got 5v plus 1. Well, what do you know? I have things in common here. 5v plus 1, 5v plus 1. So I'm going to take that out. And I'm left with 5v squared plus 6. And again, if I multiplied this out, I would get my final answer. Okay? So that's factoring by grouping. I'm going to do a couple more with you. In fact, I'm going to do a lot more with you because pretty much every problem on the next page has something special about it. So I'd love to skip and just pause it and say work, and I'll come back. But I'm going to work out most of them with you. So number 3, this problem, I'm going to check to see, do all four terms have something in common? Okay, 1, 2, 3, 4. No, they don't, right? 15, for example, the very last number, has nothing in common with all of the other ones. Has something in common with 10, but not 4 and 6 and all of them at one time. So I'm going to group. I'm going to group the first two together. I can take out a 2b squared. I'm left with 2b minus 3. Take the last two, group those. I can take out a 5. Remember, I have to have plus to join the two together. So I've got 2b minus 3. Well, what do you know? This is in common. This is in common, so I've got 2b minus 3. I write what's left over, so 2b squared plus 5. Okay? All right, let's keep going. We'll switch colors. So on number 4, I look to see if all four have something in common, and they don't. So I'm going to group the first two. I can take out a 2m squared. I've got m minus 1. Look at the last two. I can take out a 3, right? So I'm left with 1 minus m. Now, we have a slight problem here. These two now don't have anything in common because m minus 1 here is not the same as 1 minus m. Not the same at all, even though they look the same. On the left-hand side, we have a positive m and a negative 1. Here we have a positive 1 and a negative m, not the same. Okay, so I need to actually do some changing here, and I'm just going to erase. I would suggest that y'all just kind of maybe draw one line through this and start over underneath. Well, I really didn't need to erase all of it, honestly, but I was going to go ahead and just show you. So the first part was the same. I'm still going to take out 2m squared and be left with m minus 1. However, when I go to change this second half, I need to be intentional about what I take out. So I know that I want to be left with a positive m and a negative 1. Well, what do I need to take out of 3 to leave it as a negative 1? Well, I need to take out a negative 3. Okay, and having a minus there is okay. I'm going to be left with negative 1. If I take negative 3 out of negative 3m, I'm going to be left with positive m. Now, those two things are the same because I have one m that's positive, positive. I have a 1 that's negative, negative. Okay, so now that's the thing that I take out from both. And what I'm left with is 2m squared minus 3. Okay? Now, keep that in mind as we go through the rest of these because that's still going to keep coming up. Okay? We're doing number 5, and then I would suggest that we pause and take a break. But let's do 5 really fast. So on number 5, I look to see if all 4 have something in common, and again, they don't. So the first two, I can take out a 3c squared, and I'm left with 3 plus 4c. Okay? This next one, I want to be left with 3 plus 4c. right? So I need to take out a, what am I doing wrong? Hold on, I'm pausing. Oh, figured it out. This is supposed to be a negative. When I took out a 3c squared from negative 9c, this is still a negative 3. So now, I look at my right-hand side. I want to make sure that I'm left with a negative 3. So that means I take out a positive 5 from both. So negative 3 plus 4c. And again, that's what I have in common. Negative 3 plus 4c. And what's left over is 3c squared plus 5. That's my answer. Alrighty, I'm going to pause here. I'm going to continue in this video, but I'm going to pause. So I would suggest that you pause as well. Maybe, again, get up, go to the bathroom, do something, and we'll finish this out. Alrighty, so number 6. For this problem, we want to, again, check to see if there's something I can take out of all 4. And for once, there actually is. I can take out a 2 from all 4 of these terms. That hasn't happened yet, right? So when I take a 2 out, I'm left with 2a cubed minus a squared minus 3 plus 6a. Okay, that's a little different. We haven't done that yet. That doesn't mean I'm done. I actually now want to still try to group. Kind of the rule of thumb with factoring is that you just do not stop until you are absolutely positive that you cannot do any more. So now that you know how to group, you should always try to group every single time. As long as there's 4 numbers, you want to try to group. So I'm going to go ahead and look now at my 4 terms that are inside the parentheses. I'm just going to leave this 2 out here and come back to him later. So between these first 2, I know that I can take out an a squared. I'm left with 2a minus 1. Between these last 2, I'm wanting to hopefully have 2a minus 1 left over, and I'm looking and seeing that my a on my 6 is positive already, so I think I'm good to take out a positive here. I'm going to take out a positive 3. That leaves me with negative 1 plus 2a. Well, good. That left me with positive 2a, negative 1, negative 1. Okay, so I'm taking out 2a minus 1. What's left over is a squared plus 3. However, from the very get-go, I had this 2 here that I have to bring down. I cannot forget him. He goes on the very outside of this whole answer, or the answer is not actually right. Okay, so you can't forget that greatest common factor you take out at the get-go. All right, so let's look at number 7. Number 7 is actually kind of already started for you. They've already done some grouping here. The only thing that's different is when I take out the piece that's the same from both, I need to be careful about what is apparently left over, right? I've got an x squared from the first term, but what do I have from the second term? Looks like nothing, right? Looks like if you take away that a squared plus b squared, it's gone. But remember, factoring is undoing multiplication, so we're dividing here. So a squared plus b squared divided by a squared plus b squared is actually 1. And always remember, you can imagine a little imaginary 1 there. So my answer here has to include that 1, or it is not correct. But that one was actually pretty fast. Okay, last problem, on this slide at least. We are going to check again to see if all 4 terms have a greatest common factor, and they actually do. They all have 3 and h in common here. Okay, so I'm going to do that first and get left with 4 terms, and then I'll try to group again. So 3h out of 21, h to the 4th. That leaves me 7h cubed plus 24h squared minus 5h minus 6. Okay. So I've done that. This is similar to number 6 over here, right? So now I group, right? My first 2 terms, the only thing they have in common is h squared. So I'm left with 7h plus 24. Oh no. When I go to group these 2, is there any way we're going to be left with the 7h plus 24 in parentheses? No, there's no way, right? So what we've just seen is an example of a problem that actually stops. It can't be grouped. I've purposely given you a whole bunch of problems that can be grouped so far, but this is actually one that can't. Now, that does not mean that this is prime, okay? Even though we couldn't actually continue with the grouping, we still did something to it. We took out the 3h. So that means that this is my answer, okay? We couldn't group it, but that's okay. We did something. The only time you write prime is if you literally cannot do anything to what was written on the printed paper, okay? Alrighty. We have 3 more here. They're not meant to be tricky or anything like that, so I think that you could actually try these 3 on your own. So I'm going to pause the video and work out the answers. You pause and work, and then we will compare. Okay, so here's the answers to those three. The first one, you had to be a little bit careful about your negatives and things. Middle one was pretty self-explanatory. Number 11 did include that one thing. When I factored out that first grouping, I noticed that 3x plus 2 was left over, which is exactly what I had already right here. That does not mean you get to just quit it. You have to actually factor out a positive one, and then you'll have your group. Alrighty, so I got a little interrupted there at the end. Shout out to Riley for popping in my teaching. So let me know if y'all have any questions about the video. But like the last topic, you have practice that you'll work out and check your answers as you go. And there's actually two practices. There's one where it's very straightforward, like number 9 was. And then they have one practice where, I'm going to go back a slide, where you have to take out the greatest common factor, like this one right here. Okay, so 2 practices to complete and submit back to me, and then you have a quiz at the end, like topic 1. And then again, if you do well on all those things, you should move on to topic number 3.